Hello, everybody. Welcome back to our little studio, and once again, we're talking about our new project, Korea. Here in the studio for the second time, we have Sergey Vorsin, the lead programmer and architect of the project. Hey there, Sergey. Well, since that's the case, we're going to talk about the depths of our engine, about technology, and about the complex stuff. There's this channel. There's an internet channel about all kinds of space science news. The author says, "We called the channel Cosmos simply, but the topics we cover are anything but simple." We're going to have the same thing today. We're talking about complicated topics. Last time we talked about the game world. Today, we're going to talk about the graphics engine. The main topic of today's conversation is the key technologies, the key new technologies in the Korea project, and the second part will be about the development strategy. Sergey, let's start. From your point of view, what do you think is the most important thing we have done or changed in Korea in terms of graphics compared to Great Battles?
What's new? Well, to start off, some of the groundwork had already been completed during the work on the Great Battles series. We started the development of the physical atmosphere, for example. A fundamental difference, especially from a flight simulator perspective. It's the physical atmosphere because, first of all, it affects the range of visibility. With a physical atmosphere, visibility increases up to the Earth's horizon. So, say at 10 kilometers altitude, there's about 500 kilometers of visibility, which puts limits on the minimum range of visibility. For example, you cannot set it to 40 kilometers anymore.
Right.
Well, why? You can, but it won't look right, and most likely that option might not be available because with a physical atmosphere and a visibility of 40 kilometers, being at an altitude of 10 kilometers, the picture just won't look right, definitely.
So, since you're emphasizing the physical atmosphere is the key, let's explore a little bit what that actually is. As far as I understand it, it's primarily the technique of illuminating the volume of gas, so to speak.
Well,
right?
yeah, people tend to call it haze or fog or atmospheric opacity, but it's actually scattered light in the atmosphere, in the air, basically. That's what we just added. Or rather, how. It was partially implemented in GB, but we didn't add it there because the project is already complete, the content is set, and you can't change it, and users are already familiar with it. So we could only refine and include it in Korea because, well, it's a new project, and you definitely can set it all up all over again. The illumination of the air by the sun and additionally the influence of weather phenomena on it, as much as is possible to do in real time. Without getting too deep into all the technical details here, you could say this is all about sunsets, sunrises, and things like that, yes. And how it looks at altitude and on the ground, right? So it's more accurate now than it was in GB. One effect, for example, is that the curvature of the Earth's surface is taken into account. So, for example, if a plane is flying at, let's say, 9 kilometers and another is on the ground, the sun has set on the ground, but at 9 kilometers, there's still sunlight. And these effects also apply to clouds, including cirrus and cumulus. All these nuances have been added, and this is all about accounting for them. So yes, the curvature of the Earth's surface is definitely taken into account when lighting the environment.
And it's not just that an airplane might be in the shadow of the Earth. It's also taken into account that the thickness of the atmosphere through which the sun's rays pass is significantly greater at the Earth's surface, and the hue and brightness at the ground will be completely different from that of an airplane at, say, 10 kilometers.
Yes, but the main thing, of course, is to understand that the physics of light, yes, it's calculated in a certain way, but before that, the artists apply white balance and various corrective filters. So it's clear that it's quite likely that the user will still see, let's say, the result of the artist's work. Because we're not doing a scientific research project on color perception. It's a flight simulator after all. And so the physical result ultimately goes through, let's say, the artist's filters. But they are minimal.
Yes, and it's not just a coincidence. The thing is, if you just put the physical result on a monitor, surprisingly, it doesn't match our perception of reality. Because in our mind, there's also something
Well, the
similar
whole problem
to
is that there's no
HDR
clear
and white
criterion for
balance.
correct perception or correctness. Sure, there are different measures of color perception, but it's all very subjective, and it can also depend on the monitor. And everybody has different monitors.
That's why we have, well, in this case, we have, respectively, an art director, roughly speaking, Zhenya Isayev, who in our case acts as a filter to solve certain problems. About how the physical representation of light should be adjusted, a more refined physical representation of lighting in the game from the perspective of human physiology. By the way, in the latest screenshots from the last few weeks, you can already see, well, in the dev blogs that we post, you can already see the new lighting. So, aside from the atmosphere, aside from the new lighting, and the new lighting model, what else would you like to highlight here?
Specifically, what's new in Korea and how it's different. The main difference, yes, is the atmosphere. Then the physical materials, as they're called PBR, physical-based rendering. Then there's the completely redesigned water reflection system, both for rivers and oceans. The surface itself is still being refined, but there will definitely be different reflections in the sea and river water in terms of the perspectives of the reflections. So what else do we have? Well, for instance, we have a new API, for example, DirectX 12. Yeah, there you go. There are actually a lot of improvements. Many people tend to compare, let's say, us to Digital Combat Simulator. That's not quite correct, because for one thing, not only do these projects focus on distinctly different time periods, but you could say that one project is a pure flight simulator, while we're more focused on a hybrid model, meaning both ground vehicles and air combat. And the ground details in particular are constantly being refined. For example, different lighting elements are being added. For instance, lights in the cities and lights along the roads, that sort
We
of
have
thing.
worked on improving the grass.
Grass, yes. Completely new trees, yes. And some things have been added there. Well, naturally, let's say. All of these technologies are being refined to maintain an acceptable level of performance when playing the game in virtual reality. For example, there are different rendering methods for trees, like what are called shooter game trees. On the other hand, in MSFS they use cardboard trees that look good from a distance. Basically, there are about 3 polygons. 3 polygons. It's possible that some places have detailed ones, but basically, let's say, the trees are much simpler than even in DCS.
Well, at least in the 2020 version, we
Yeah,
studied
well,
it very
basically
thoroughly.
the point is that all of these graphical changes in the vegetation are primarily focused on performance. Because even though we have both a ground simulator and an air simulator, the priority is still on the air environment. Hence the longer viewing distances. But we are still trying to move towards more detailed ground environments. A lot of attention is also being paid to the landscape below. Because originally we had a project about battles as a whole, great battles.
However, at the same time as we are actively working to improve the level of detail on the ground, still, in Korea IL-2, we have another record size of terrain, again, 500 by 500
Well, it comes from the
kilometers.
historical theater of the war.
The madness of the brave comes with
so
a song,
basically
as they
we're
say.
moving forward. We're doing a flight simulator, but we're also trying to get into some of the ground technology. Ideally, of course, the perfect project would be, from our company's perspective, is a kind of universal battlefield, but the primary focus is on aviation. This is about aviation, of course, because large spaces and open worlds really drive technology. You see, shooters have already reached their limit, racing games as well, but in terms of flight simulators, well, the technologies are really in their infancy. The graphics card is pretty weak for flight simulators because if you want to see the whole space from, say, imagine that you want to see everything from, say, 15 kilometers altitude down to a human in one project. It wasn't done yet in an effective way because the level of detail and amount of content required is very different. The worst altitude is 50 to 100 meters, 150 to 300 feet. It is very detail-heavy, and unfortunately, graphics cards are not there yet to render this amount of detail. The level of detail, the number of polygons, so to speak, yes, to cover a height of 50 to 100 meters,
Let's explain a little bit about why this is happening. At this altitude, you should still see the fine details that we see up close on the ground, like super detailed grass and detailed trees.
Not just this.
But at 100 meters, you see too many of them at once.
Yes, your view range increases a lot. For example, when we talk about the terrain, it's not just grass. You've got all kinds of little details like ledges, cliffs, rocks, etc. Then the rivers should inherit the curvature of the shore. The shore, right? So, for example, if you need to cover the distance from 50 meters to, well, when you're on the ground, your viewing distance is basically limited by the horizon, trees, or other objects, so it's literally a kilometer or two, even though we render it much farther, yeah. But at altitude, starting from 1 to 2 kilometers, the range of visibility jumps to about 20 to 100 kilometers, depending on the weather and the terrain. So technologically, we are still at the beginning. Unlike usual shooters where they have already mastered drawing buildings and characters, graphics card manufacturers aren't really focused on open-world development. Rather, they're all focused on movies, really, on ensuring corridor rendering of a small space. And also, let's not get sidetracked, but basically, the goal is to get closer to the ground in terms of graphical richness. Of course, the flight simulator remains the priority since it was originally the IL-2 project. Well, yeah, and we have added a lot of details like three-dimensional railroads, railroad crossings, all of that sort of thing.
Well, at least because such detailed models that we're now making for Korea, like the same locomotives and railcars, would just look ridiculous otherwise.
By the way, it's also worth mentioning that there are people who think that if we make three-dimensional rails, for example, we won't have any AI planes. Or, for example, we'll
like
make
that.
arcade flight models. Like the aerial combat will just lag more. The point is that different people do this work, and there are even specialists who are dedicated to it and, let's say, enjoy doing it. So forcing them to build a flight model would be a very thankless task.
This, my friends, is called specialization.
Yeah. So it's not just a bunch of goblins sitting there all wearing the same colored shirts and hats, but actual people working in different areas. And if someone is focused on, let's say, ground elements, it doesn't really affect, for example, aircraft carriers and their landing physics. Absolutely.
Yes, but it should be clearly understood that the development of all these technologies boosts each other. Roughly speaking, when we were working on tanks, a lot of people complained about why we were spending time on tanks when the engineers were not really spending time on tanks. As a result, tanks led to an enormous amount of technological innovation. Then they eventually transferred to airplanes, including Korea. The damage model there is more interesting, the cockpit animations are more captivating, and the effects will be better. This is because when we started working on tanks, we got a new development boost in the engine, which led to significant advances in various technological areas. Entirely new technological directions were developed here, and then it ended up having a positive impact on the aircraft as well. So let's talk about that. You have mentioned DirectX 12 being integrated into our new project. Let's take a moment to explain what DirectX actually is, because for a lot of people, it's like a spell out of Harry Potter. DirectX? What is it? Nobody understands. What does this word mean? Why should we even support modern DirectX? Why is version 12 better than version 11?
Well, DirectX, like Vulkan or OpenGL, are all graphics APIs, right, that developers can use for rendering. Well, it's sort of the top-level API for displaying various graphical information through a GPU.
API, Application Program Interface? Interface
Yeah.
between what?
Well, between, let's say, the developers and the graphics driver,
So
basically, to put
basically,
it
the path to the
simply.
graphics chip is from the game through DirectX. DirectX communicates with the driver, and the driver then controls the hardware on the video card, its transistors, basically.
Yes, I would say the differences between DirectX versions 12 and 11 are extraordinarily significant. Even if we don't have inside information from either Microsoft or NVIDIA, as a developer, you can definitely see that the development philosophies are completely different between the two versions. For example, API 11 and 12 and DirectX, they are drastically different. I mean, the Microsoft development team specifically for DirectX, they tried to maintain, let's say, the familiar traditional environment. Yeah, they haven't renamed everything, but the philosophy has changed a lot, you know. In fact, I would say it looks like the team has completely changed because, for example, what is the main benefit of DirectX 12? The main benefit is, let's say, multi-threaded rendering, which means you can do rendering tasks on multiple cores at the
Some
same
more detail
time.
here, as there have been a lot of questions about multi-threading.
Well, what that means is that if you create a frame efficiently right now, say with Vulkan or DirectX 12, you can also efficiently process the rendering of the frame on multiple CPU cores simultaneously, ideally across all cores. However, there's a nuance that everyone tends to overlook, but we'll get to that later. The main thing is that yes, the frame is actually built on multiple CPU cores, so that the accelerator can later render it all on a texture or screen using its thousands of cores. So what do we have here? Actually, there's a suspicion as to why the teams changed. Because, for example, in DirectX 11, they already added in principle the concept of different contexts. So this is, let's say, a context for execution. In DirectX 11, to put it as simple as possible, there was already the capability to do multi-core rendering. They had already laid the groundwork for that sort of thing. However, in version 12, let's say, they started everything from scratch, like resetting everything and building their architecture from the ground up. Basically, they started from scratch. They placed a lot of critical sections or something, but it's hard to say. Basically, the point is that if in DirectX 11 everything was drawn in one thread, now the same approach won't work because DirectX 12 has gotten heavier in terms of single-thread performance. Critical sections added up, or something else, it's hard to say. Basically, the point is that in a single thread, like in DirectX 11, we used to render mostly all in one thread. But now that won't work because DirectX 12 has generally gotten heavier from a single thread perspective. So now the frame is formed. Well, in Korea, since Great Battles uses DirectX 11, and Korea will have 12, maybe Vulkan most likely. But the point is, yes, the frame is formed on multiple cores. Right now, 5 cores are being used, and the number of cores is actually limited by the specifics of the API. Well, let's say the specifics of the API. Yes, you can use more cores, but however, you might run into some API limitations. That said, in general, the point is, yes, frames are already being formed on multiple threads. On a single thread, the same thing works about 3 times slower. On DirectX 11, we get, let's say, about 100 frames per second. However, if we decided to use the same approach in DirectX 12, we would end up with far less, only about 40 frames per second. So, what's the problem here? The problem is that we had to redo the project significantly. Let's explain it this way. The graphics pipeline had to be completely revised. We had to add scene graphs because that's the only way it is possible to distribute the frame across multiple cores.
A little bit, very short. What is a scene graph?
All right, well, basically, this type of layout can be represented as a graph. It is something you could even draw on a piece of paper. So, to put it simply, it is a scheme that describes which rendering nodes are currently in the frame. Well, to explain it simply, it's a scheme that describes the order of the construction of a scene.
In other words, There are certain processes, and so each process is a stage of frame preparation that describes what's coming next.
Yeah, well, like what to expect. Actually, there are some, for example, graphical effects. Certain, let's say, stages of rendering, like the propellers from the cockpit when you're flying. And you have the close-up view, the far view. Those are all rendered separately because it's partly related to optimization because we don't need to draw what's behind the cockpit. It's about not drawing what's behind the cockpit. Secondly, it's related to the cockpit canopy because it's quite complex. Different effects there, something inside, different outside the cockpit. This kind of stuff. And it's all kind of managed by a graph that's now, which is actually the rendering pipeline, yes. And we can certainly split it into different threads, specifically on different cores of the processor. So what else is there to say about this? There is a lot to say about DirectX 12, but
Well, considering that we've already talked for 20 minutes,
yes.
I would suggest that since we've basically outlined the main directions that are probably fundamental, now that we've covered the main directions for the engine, I'd like to talk a little bit about what we're planning for the future, possibly after release. What directions do you see development going in? Where do we think we are going? So it means you determine where we are heading in terms of graphics technology.
Well, in terms of graphics technology, yes, we kind of plan to increase the level of detail in the ground part. That's the first thing. And then improve the quality of the air component, which is the clouds and the atmosphere again. There's room for improvement in the atmosphere. Even though it's physical, there's still room to add, let's say, improvements. There are tasks that can be done even better and that can make a noticeable difference in the visual results. For example, what we see now in Microsoft Flight Simulator, yes, their model of the atmosphere, or the DCS model, or what we're going to have is basically a good option, but there's still a lot that needs serious improvement, and for now, well, there's no quick fix, at least not in terms of performance. So what else is there? Well, we definitely will continue working on the atmosphere, because it affects the aerial view. The ground view definitely also needs to be more detailed. Well, when it comes to the subject of the ground view, that's a whole other topic, let's just say. Let's say it's a separate class of tasks. The thing is, it's a task. Right now, for example, we've added something that was begun in Great Battles. Specifically, we added displacement, or rather the tessellation of the terrain volume, is unfortunately often heavily suppressed by artists. As a result, users think the ground looks flat. Well, the ground, when we're standing, the surface of the ground itself, it's actually uneven, but the way it's been artistically drawn makes it look less uneven. So, well, basically the plan is to improve the detailing and the polygon count and to integrate three-dimensional roads into it. Not just flat ribbons, but specifically with ravines, with ruts, all that. Yes, with shoulders. So the current technology allows us to do that, but we have to apply it. This will give a correct picture and correct behavior of the ground equipment on the ground. That is, now our machine can just drive off, but this way it will drive into an obstacle. As for the surface of the water, we have already improved the reflections. We have reworked them quite a lot.
We'll show a screenshot.
Yes, the water surface will continue to be worked on. More Fourier harmonics still need to be added, for one thing. There is still a lot of work to be done, yes. As for the rendering of the surface of the water, that's an entirely separate set of tasks that we are working on. In principle, we plan to improve it even more, probably for the Pacific. When we talk about the Pacific, these are future projects.
Yes, I mean, we have definitely opened ourselves up to this possibility. Yes, this was something we talked about when Roman was here. That is our goal. Those plans have yet to be approved. We're just waiting.
Yeah, and then we will kind of get additional tasks thrown at us, right?
We will not speak of them.
So what's the plan for the Pacific? It's expected that carrier operations will return, right? We already have working prototypes for aircraft interaction with the flight deck. So if you think about a carrier and our simulator, we really want those planes, for the player in the plane, and those planes to take off correctly, like from the elevator and everything. If we have an elevator, that means we also have a second lower deck.
Yeah? Shaded volumes?
Yes. And now we've started working on ambient occlusion for the open world. This will not be like it's done for shooters, where radiosity is baked in and light probes are embedded, but we will be addressing those kinds of tasks for the open world environment. And because of all this, most likely, we will be able to successfully display these correctly. The second lower deck, or what is known as the hangar deck, and the player's plane within this deck. Again, it's about different hangars at airports in terms of the ambient lighting. What else is there to say? Honestly, not much has been said, but there's a lot of work to be done. And of course, there will be even more.
Yes, you have to understand that behind every word, we just talked about it for a couple of minutes, and a dozen sentences were said. Behind each of those sentences, there might be more than a month of work, something like that.
Well, sometimes even for 4 months, someone in the team has been working on something for this time. But that's not the point. The point is, yes, the point is that there are plans, big plans. It's all about time and priorities. So the leadership is the one who sets the priorities, at the request of the players, but not everything can be released at the same time. Some things will be released earlier, some later. We're trying to get as much as we can into Korea on release.
Well, we'll see how it goes. I think the competition will be a little worried when Korea launches. Yes, our competitors, they are doing well.
Well, the competition is doing fine. They don't have to worry.
We'll see. We've been talking for almost half an hour now, so let's move on to the questions submitted by our viewers. Okay. People were asking a record number of questions on this complicated subject, so we certainly won't have time to discuss them all now, but let's pick a few. They are asking about RTX graphics features. Will we be using them in the game? So, just a few words about RTX and its general applicability to IL-2.
Well, RTX is basically not a bad technology that NVIDIA has been aggressively pushing into the market. Well, let's just say we want good virtual reality with great image quality, and RTX is kind of, well, it's an important thing. Let's say, we'll look into it, of course we'll look into it, but at the moment we're not focusing on it, although research is planned. But let's say we're not getting our hopes up right now because, as I said, RTX, first of all, has a strong impact on performance, sometimes with the same visual quality for the player. RTX has a big impact on performance, so we will look at it, and as soon as there is an opportunity, maybe we'll use it, but at the moment, let's say the affordable graphics cards for an open world with RTX are, well, still a bit weak.
Question. They ask if we can use the improvements we've made to the graphics engine to implement infantry trenches.
It really depends on how the players perceive infantry trenches. Technically, we can create them, but the important question is how many and what will they look
that's
like?
Right.
So we can nominally make trenches, yes, but the question is how well it will work visually. The artists will have to tell us the answer to that.
Yes, so the situation is we recently showed craters that cut through the ground, right? Basically, this tech can be used to create trenches, but the question is one of quantity. You cannot cover the entire map with hundreds of kilometers of front line, as you need with World War I. It will hit performance badly. So in some selected places where a mission takes place, if you fly there and there should be trenches, we can certainly do that, and maybe we will. But if we are talking about the type of trenches you need for a World War I scenario, it's probably too early to discuss that sort of thing. Here is another question they are asking. Will it be possible in the future for the engine to render large, open areas of the sea with different water textures?
Probably, yes. But again, that's a question of the development of the ocean rendering. But basically, it probably won't be a problem because we already added PBR, and the water surface at a distance is, let's say, a special case of PBR. So in principle, it's doable. The only question is how much memory it will use and, well, and what to do about tiling over large areas, because the areas are really huge, like in the Pacific or Korea, where there are huge bodies of water, and tiling should not happen. Well, it's potentially possible, but we'll definitely look into that.
By the way, let's comment on why this is a special case of PBR. What is PBR? Roughly speaking, it is a texture map that describes the properties of the surface. In other words, where it's rough
No,
and
well,
where
you're
it's not.
talking from an artist's
I'm
point of
leading
view.
up to something. When we talk about water, these local variations in the water at a great distance are also basically the roughness of the water.
Well, for the average person, yes, you could say it like that to make it easier to understand.
All right, so they are asking, why is there so much mist everywhere in all of the screenshots you post, like everything is in mist, like there's so much haze? I'll probably answer that by saying that we think it looks nicer that way. Yes, there are weather conditions where you have very clear air and minimal haze, and you can do that in the weather settings in the mission editor, but we like it less that way. So in the screenshots, to give depth and distance, we usually add more haze because that's what we prefer in the mission editor. As artists, we think it looks better this way, but you in Korea can set a mission up for clear weather. Go ahead, everything will be in your hands, everything will be provided. Here's another question. How will the system requirements change in Korea compared to Great Battles? People are really worried about that. I guess we can say that in terms of requirements for the performance of the video card, not much, right? But in terms of memory, significantly, in terms of video memory.
Well, I wouldn't say that. We have improved the vegetation, but vegetation that is close to the ground really eats up a lot of performance. So the graphics cards have to be a little bit more powerful.
Here's the situation. Great Battles was released on Steam in 2014, exactly 10 years ago. At that time, it worked relatively well with graphics cards that were 1.5 or 2 generations behind. The release of Korea will be exactly the same. A 3060 series graphics card will work just as well. It would work pretty well if you use the appropriate settings. It probably won't be enough for VR. If you set the appropriate graphics settings, because it's not the most powerful video card, you have to understand. And you can definitely play quite well in Full HD with a good image. The FPS will be good, and 6 gigs of video memory should be enough for you. But if you have 4K, or if you have VR, in that case, yes, the video memory requirements really go up. And for the best possible picture quality, you're going to need a powerful GPU with lots of video random access memory, something like the 4080. This is how it always was. All right, so here is the next question. Will you have a round Earth in Korea, or will it be flat? Here's what I'm going to say. If you're asking this question while looking at our screenshots, it means it's not really necessary. Because if you don't notice in the screenshots that we provide that the ground is not round, that means on a map scale of 500 by 500 kilometers, it's not very important. In addition, the new atmospheric model addresses this sort of
Well,
thing.
flying 500 kilometers, you can actually notice the difference. You can fly around in a special way and notice that you are flying in a Euclidean space. But actually, that question is not really. This is more for management than for developers because it's about the overall strategy of the project. The round world and everything related to Microsoft Flight Simulator is more of a management question.
Well, the thing is, since we're focusing on more local scenarios, not super global conflicts or worldwide flights, it's not a very relevant task, especially since there's the issue of historical maps. Then the map has to be reproduced as it should be. Well, yes, because satellite images are all modern, there are no satellite images from the year 1950. Yes, so that's true for us. Nevertheless, in terms of appearance, if you look at screenshots from 10 kilometers away, you can see for yourself the horizon diminishing, and the curvature of the Earth is noticeable, so everything looks as it should. And now the last question for today. Which programming language do you use, and why?
Whoa! Well, we program mostly in C++. As for the version, that's an entirely different discussion. But C++ has been around since the rise of Flight series.
And why exactly C++ and not Python?
Well, it's because, let's say, it's the language that allows, let's say, high-performance real-time systems. There are specialized languages, but in this case, if we are talking about a flight simulator or a modeling system, then in fact, the C++ language is generally well-suited for this. It has a very convenient system of operators, for example, and the mathematical framework can be wrapped around it very well. Also, since it is quite similar to the C programming language, you have the ability to implement some time-critical parts directly in C. Oh, and by the way, there are often a lot of such parts in simulators, and not only in aviation ones. We also actively use single instruction, multiple data processing, since this gives us the ability to create multi-vector computations, unlike, something like C# or maybe Python. And yeah, when we talk about multi-threading, it's present in many programming languages, right? But, for example, a multi-threaded render, right? It really needs to be, let's say, as efficient as possible. And that efficiency is not just in the code that the programmer writes, but also in how fast the processor handles context switching in the thread and so on, sometimes depending on the compiler. So, for example, something like Python, as far as I can remember, is more single-thread inclined. Well, basically, C++ is the optimal choice here, that's all. Not because we love C++.
Simply because they are best suited for this task in terms of optimization. That's it. Thank you very much. Friends, subscribe to our channel if you like this format, and keep watching our videos. Please like the video. We will be grateful to you. See you soon.